All right, in this video we're going to go over some code examples that might help you get through Nitro 3.4. So after the code examples that they had for us to look at, they want us to write a little if, else statement to determine if a number is positive, negative, or zero. So first of all, we have to ask our user for a number, and to do that we need a scanner object. So I like calling mine my input equals new scanner system dot in, and then let's print system dot out dot print line. Let's print enter a number, and int my number is my input dot next int. So now we want to do certain code depending on the size of that number. So first of all, and it doesn't really matter what order you do this in, there's a couple different ways to do this and get it right, but I'm going to say if my number is greater than 0, then for sure we know the number is positive. So we can say system.out.println the number is positive, exclamation mark. I'm just trying to match what they have going on over here. Okay, and then we could say if my number is less than 0, then that means it's negative. And we can do something like this, system.out.println number is negative. And then we can do another if statement. If my number equals 0, then we're going to print out the number is neither positive nor negative. So this is not using an else if yet. This is doing it with 3 different if statements. Enter a number, 10. The number is positive. Enter a number, -5. The number is negative. Enter a number, 0. The number is neither positive or negative. So that's working the way we want. It's just not working using the if, else structure. So instead of doing this as 3 separate if statements, it's going to be all one big if statement. So we're going to have if the number is greater than 0, then print out that it's positive. Otherwise, else, if the number is less than 0, then we're going to print out that the number is negative. And I don't even need this check, because if it's not greater than 0 and it's not less than 0, then that automatically means that it is 0. So I can just say else this. So you might be wondering why that is preferable to doing this. Let me just put them both on here. So if it's greater than 0, else if it's less than 0, else do this. So why would one be preferable over the other? First of all, the benefit of doing the if statement this way is this. When the first condition is true, so if the number is greater than 0, it's going to print out the number is positive, and all of this other stuff that is part of the if structure will totally be ignored. Down here, this way of doing it, if the number is positive, it'll still print out that the number is positive, but then since this is a separate if statement here, it's going to go ahead and check whether or not it's greater than 0. And since this is a separate if statement here, it's going to go ahead and check if it's equal to 0. So it's going to check all three of those, even though it already met the first one. So that's one piece of, I guess, not redundancy, but not ideal programmatically. The other thing is that you shouldn't have to check to see if it's 0. If greater than 0 is false and less than 0 is false, then that automatically means it is 0. So you really even don't have to do this comparison if you structure it all within the same if statement using else and if else. So, assuming that all that was done correctly, we should be able to enter the same three numbers and get the same three correct results. So we're going to enter the number 10, it's positive. We're going to enter the number -5, it's negative. And then we're going to enter a 0, and it's neither positive or negative. So when this condition is true, this line of code executes, and none of the rest of the if executes. If this condition is false, then it checks to see if this condition is true. And if this condition is true, then this executes, but the rest of the if statement does not execute. If this is false and this is false, then it's going to do the command or the code that's in the else condition. Now, I should point out that there's another way that you can do this and get it to work correctly as well. Well, there's a couple different ways. You could check to see if it's greater than 0, and if it is, print out that it's positive. Then you could check to see if it's equal to 0, and if it is, then print this out, that it's neither positive or negative. And if it's not greater than 0, and it's also not equal to 0, then that means the only thing else that's left is that it's less than 0, which means it's negative. So this will also print out the correct response, or the correct output. So if I type in the number 10, they should both say the number is positive. If I type in the number -5, they should both say it's negative. So both of those will work exactly the same. Now, I tried to follow what they said in the assignment, which is first check if it's positive, then check if it's negative. If it's neither one of those, then it must be 0. But that's not the only way to structure this and get it right. Anyways, let me get rid of this and test cases, and we should be okay as long as there's no spelling errors. So that's 3, 4, 6 of Nitro. Now on to 3, 4, 7, which is about salmon spawn. So in this little section, we're going to have the user enter the month as an integer. And if that month is from 3 to 6, that would correspond to March to June, and that would be the spring spawning season for salmon. If they enter a number from 9 to 11, that would be September to November, that would correspond to the fall spawning season for salmon. But if it doesn't meet any of those criteria, then we're going to say it's not spawning system, not spawning season. So they've already got the scanner object ready for us. So we're going to create an integer, we'll call it month, equals input.nextInt. And actually before that, we should prompt the user for what we want. System.out.println, enter a month, and I'm going to put in parentheses 1 through 12 like that, so they know I'm expecting a number. And then if the month is less than 3, then it is not spawning season. So we're going to say something like system.out.println, system.out.println, not spawning season. Okay, if it's not less than 3, then that means it's 3 or greater. So if we get to here, then we know it's 3 or greater. So if it's less than or equal to 6, if it's less than or equal to 6 and we get to here, that means it's great. It's 3 or more, but it's less than or equal to 6. So that's going to be our spring spawning season. So we're going to say spring spawning season. If it's not less than or equal to 6, then that means it's greater than 6. So if it's 7 or 8, then it's again in the summer and not spawning season. So we're going to say else if the month is less than 9, which would mean it's 7 or 8, then we're going to say system, we're going to say the same thing we said up here, not spawning season. And then another else if. So if it's not less than 9, then that means it is at least 9. So we're going to say if the month is less than or equal to 11, then it's fall spawning season. And if all of those fail, then we're going to say it's not spawning season. Okay, so let me add in, well, they've kind of given the comments here, but I'm going to add comment at the end of this if here. This means month is 1 or 2, January or February. So we print that it's not spawning season. Else if the month is less than or equal to 6, this means month is 3 or 4 or 5 or 6, which is March through June. March, April, May, June. So realize that if it's less than or equal to 6, it can't be 2, because if it was 2, then this condition would be true. And remember, if this condition is true, then this line of code here executes and the whole rest of the if is ignored. So for us to get to even checking this conditional here, we know that the month is at least 3. So if it's at least 3, but less than or equal to 6, then that means it's 3, 4, 5, or 6, and that's spring. If it's not less than 3, and it's not less than or equal to 6, but it is less than 9, then that means the month is 7 or 8, which would be July or August, and that's not spawning season. If it's not less than 9, and we get to this comparison, but it is less than or equal to 11, this means that month is 9 or 10 or 11, which is September through October, November. And then it's fall spawning season. And if all of those fail, if the month is not less than or equal to 11, this means month is 12. and that's not spawning season. So I think I just want to check the code right there. And that all looks okay. They make a really interesting point here. If you entered 2 for the month, all of these are going to be true. If the month is 2, then that's less than 3, and it's also less than or equal to 6, and it's also less than 9, and it's also less than or equal to 11. But if the month is 2, then this condition here is true, which means this line of code gets executed and the entire rest of the if statement is ignored. So let's just double check all of those conditions. If the month is 1, it's not spawning season. If the month is 2, it's not spawning season. If the month is 3, we're in the spring. If the month is 4, that's spring spawning season. If the month is 5, that's spring spawning season. If the month is 6, that's spring spawning season. If the month is 7, that's not spawning. If the month is 8, that's also not spawning. If the month is 9, that should be fall spawning season. Or if the month is 10, that's also fall spawning season. If the month is 11, that's fall spawning season. And if the month is 12, that's no longer fall spawning season. And technically, we should make it, technically we would have like a way of forcing them to enter a number 1 through 12. But if they enter something that's not 1 through 12, like if they enter month 0, then our code is going to say that's not spawning season anyway. Or if they do something goofy and say month -5, well, that's going to be less than 3, so it's not spawning season. Or if they say something goofy at the other end and enter like month 15, that's not spawning season either. So I think that's going to all work just fine. And we're on to the next section of Nitro 3.4, which is 3.4.8, which is about berries. Okay, so here we're getting some input from the user, and based on a single letter of input, we're going to know what kind of berry they're talking about. Now, this does not start off with a scanner object, so we've got to create our own scanner object. And then we're going to ask the user for to input a letter. I'm going to call it this letter, and I'm going to say my input dot next line. But first I should print out something asking them to enter system.out.println. And let's see their example here. It says enter the initial of the berry. And so now what we're going to do is we're going to create a char or a character by looking at, let's call this berry instead, this berry, and we're going to do this berry dot char at 0. So that's going to give us just the first letter of what they entered, and we're going to say, we're going to call it something like this letter equals this berry character at or char at 0. So now we can say if this letter equals R, then we know they ordered a raspberry. So we're going to display that you ordered a raspberry. System.out.println, you ordered a raspberry. Okay, and then I'm going to come back to fill in a little bit more, but I just want to make sure this is working. Otherwise, if they don't enter an R, for right now, let's just say berry not recognized. So let's start off by just handling the R. So now if we run the code, oh, I gotta have this in single quotes because this letter is defined to be a char, and we use single quotes for the char, not double quotes for the char. So let's try this again. Enter the initial. If I put R, you ordered raspberry. If I put any word that starts with R, it's just going to look at the first letter, and that's an R, and it's going to interpret that as raspberry. If we enter any other letter, for right now, it's going to say berry not recognized. Okay, so then let's fill out the rest of these with some else if. Else if this letter equals H, then we're going to say you ordered a huckleberry. And then we can do another else if the letter equals a G, then you ordered a, with a space it looks like, a goji berry. And if it's not an R and it's not an H and it's not a G, then we're going to say berry not recognized. So now if we do an R, it should know that's raspberry. If we do an H, it knows that's huckleberry. Even if we type some word that starts with an H, it's just looking at the first character, which is an H. And if we enter a G, it knows that's goji. And if we enter anything else, it's going to say berry not recognized. So that's all we need there. Okay, so all that looks like it's working out fine. So we are on to the next piece. We're done with berries. Now we're on to 349, which is about battleships. So we got a ship tester and a battleship class. Okay, so in the main, we are creating 3 different types of battleship. One is called a sub, one is called a raft, one is called a destroyer, and they each have different amounts of power, 6, 2, and 9. And then we're just printing out the names of those 3 and how much power they have using the get power method in the battleship class. Then we're going to have the raft attack the sub. So for the sub, it's getting attacked, and it's getting attacked by the power according to the raft get power. And so after the sub is attacked, we're going to print out the sub, which is going to redisplay what the sub's new power is. So if we come over here to the battleship class, they want us to finish the instance methods is attacked, is still floating, and that's it. So is attacked over here. Is attacked. So when we get attacked, this is our if statement. If the attack power is less than 4, I'm just going by what this says right here. If the attack power is less than 4, then the health of my current ship will go down by 3. So if the ship that's attacking us has an attack power less than 4, then it inflicts 3 damage, which is going to reduce our health by 3. Else if the attack power is less than 8, So it's greater than 4 but less than 8, then our health is going to reduce by 5, according to this statement right here. And otherwise, else, our health is going to reduce by 7. Because if the attack power of the ship is 8 or more, so that means it's not less than 8, then we automatically get here and we inflict 7 damage. So then each of those is attacked. Every time a ship is attacked, its health goes down. We're just determining how much the health goes down depending on the attack power of the ship that attacked us. And then for still floating, all we have to do is return true or false whether or not the ship is still floating. And the ship is still floating if the health is greater than 0. So if health is greater than 0, then we're going to return true, meaning true, the ship is still floating. If the health is 0 or negative, then we will return false, meaning that the ship is not still floating. So let's see if this will run, first of all, without error. Let's click over here on the ship tester. So we created a battleship called Submarine with attack power 6. We created a battleship called Raft with attack power 2. And we created a battleship called Destroyer with attack power 9. Submarine 100. So why 100? Because by default, the health of the ships is all starting off at 100. So Submarine with health 100 has power 6. Raft with health 100 has power 2. Destroyer with health 100 has power 9. So the Raft, where are we at here? The Raft attacks the sub. So the Raft has attack power 2, which is less than 4, so it should inflict 3 damage, which is why the Submarine now has a health of 97. The Destroyer attacks the Raft. The Destroyer has an attack power of 9, which means it's going to inflict 7 damage, which is why the Raft now has health of 93. And if the sub attacks the Destroyer, the sub has an attack power of 6, which is more than 4 but less than 8, so it's going to inflict damage of 5, which is why the Destroyer's health goes down to 95. And if we wanted to do this over and over again, let me do one part of this over and over again. This would be beautiful for a loop, but let me just do this here. Let's do that a whole bunch of times. Destroyer attacking the Raft. Try that one more time. That'll take us to -5. So after doing all that, if we do system.out.println is Raft afloat, and then we're going to do Raft still floating. I think that's the method. Go back over to here to Battleship, still floating. So we're going to do Raft still floating, which should return either true or false. So if I do that up here, let's say right there, so Destroyer attacks Raft. Raft's health is down to 9. Destroyer attacks Raft. Raft's health is down to 2, which is still greater than 0. Is Raft afloat? True. Destroyer attacks Raft again. Raft health is now at -5, and is raft afloat is now false. So I was just making sure that our still floating was going to work properly. So now let me get rid of all of this. That was all just to see if that would work. So let's do our test cases. And it looks like that's all great. So we're ready to proceed. So that is Nitro 3.4.